One of the hottest open source projects of 2026 isn't yet another big model. It's something called OpenClaw, an AI agent that used to go by Claudebot and Moltbot. And in just a few weeks, it has picked up tens of thousands of GitHub stars and turned into a full-blown phenomenon. What are people actually using OpenClaw for? To automatically clear their inbox, manage their calendar, fill out forms, write code, and even haggle with customer support for discounts while they're asleep. It's not a slightly smarter chatbot. It's a digital assistant that really does things on your behalf. In this video, I'm not going to walk you through how to install or configure OpenClaw. Instead, I want to talk about a much deeper question. When more and more people start running this kind of AI agent 24/7 at home and in the office, what happens to the compute behind it and to the power systems behind that compute? Let's start with a 1-minute explanation of what OpenClaw actually is. At its core, it's an open-source AI agent runtime, not a model. It wires different large language models into your local tools and apps, giving those models hands and eyes so they can actually operate on your machine. OpenClaw runs on your own hardware, your PC, your server, or a VPS you control. Through a local gateway, it connects LLMS to your messaging app's browser, file system, and other tools. All of its memory and configuration live on your disk, not on some vendor's cloud account. The really important part is that it's not built for you send a message. It replies once, then goes idle. OpenClaw is designed as a long-running background process with its own heartbeat. It regularly checks your email, your calendar, your task lists, and when it spots something it can help with, it acts automatically. That means AI is no longer following your workday. It's working for you 24/7. With traditional ChatGPT-style usage, what you get is bursty inference. You open a web page, ask a few questions, close the tab, and the system does nothing in between. From a power perspective, that looks like a load curve with clear daytime peaks and nighttime valleys. OpenClaw-style agents flip that pattern. They're continuous inference, always resident in the background, constantly watching for triggers, and firing off many small inference jobs throughout the day and night. On the grid side, that turns a spiky time-of-day-driven demand pattern into a flatter, round the 5 o'clock baseline for compute. Let's start with layer 1, power use at home. More and more enthusiasts and developers are parking a high-end GPU machine at home, dedicated to running local large language models and personal agents. That box isn't just for the occasional game anymore. It's sitting at high utilization for long stretches of time. A high-end consumer GPU can easily draw a few hundred watts under load. Add the CPU and the rest of the system, and a 400-600 watt sustained draw is completely normal. In the past, the main stars of residential load were air conditioners and water heaters. Now, you're stacking on top a compute load that basically never sleeps. For neighborhood transformers and household connection limits, that's a structural shift. Layer 2 is office power. OpenClaw-style agents very naturally become shadow AI. Tools that individual employees install on their own machines, secretly wired into work email, calendars, and document systems. The result is simple. Offices suddenly have a fleet of high-duty workstations and small servers that may not really go home at night. As companies grow more comfortable with the idea of agents, many will deploy internal agent platforms. These typically live in server rooms or edge racks inside buildings, where they need low latency and high reliability, which in turn demands better power quality, redundancy, and cooling. Traditional office gear. That means rethinking building distribution, UPS setups, and how those micro-server rooms are electrified. The third layer is the one everyone is already talking about, data center power. For the last few years, most of the debate focused on training, how many megawatted hours it takes to train a single large model. But it's becoming very clear that over the long term, inference is what eats most of the energy, not training. In an agent world, inference has some new characteristics. First, the number of calls explodes, not a few prompts per Dalton Y, but continuous workloads with triggers firing every minute or every second. Second, the load becomes extremely spiky on very short timescales. A single workflow or event can pull a lot of power in just a few milliseconds. Third, there's no longer a clean nighttime trough, because the agents are online all the time on every continent. If you stack these 3 layers together, you start to see the full picture. From homes to offices to hyperscale data centers and edge sites, the way society consumes electricity is quietly being reshaped by AI agents. So where are the pain points on the power side? And where are the opportunities? The first big opportunity is in power distribution. Inside data centers, rack-level power has jumped from the old 15 kilowatts range to 40-80, even 100 plus kW for AI racks, and legacy low-voltage distribution and UPS architectures are straining to keep up. The industry is already moving toward higher efficiency solutions, like high-voltage DC distribution and solid D-state transformers. And that opens a huge market for new equipment and turnkey solutions. The second opportunity is microgrids. More and more large AI data centers don't just want a big wire from the grid. They want their own generation, storage, and intelligent controls. Effectively a self-contained power system wrapped around the compute campus. When the main grid is healthy, they help with peak shaving. When the grid fails, they island themselves and keep the compute running. In new builds, you're already seeing serious evaluations of gas turbines plus storage, renewables plus storage, and even fuel cells, and in future, small modular reactors. From the power sector's perspective, each AI campus is basically a brand new mini-grid that needs full-stack design, equipment, operations, and optimization. The third opportunity is energy storage. In the old world, data center batteries were mostly treated as backup, something that kicks in for a few minutes during an outage. In a world of wildly fluctuating AI loads, storage turns into a power buffer and frequency control device that participates in operations almost all the time. Put all these threads together, and you get a complete loop. OpenClaw-style agents pull compute back from pure cloud into local and edge setups, and they turn power demand from a centralized time-box pattern into a more distributed, always steady-on network. At the end of the day, the frontier of compute runs straight into the frontier of power, and the future of power is being rewritten by AI.